Next chapter, external landforming processes. Now, we talked about the internal landforming processes in Form 2, such as folding, faulting, volcanicity, and tectonic movements. We call them internal because the forces driving these processes originate or operate from the interior of the Earth. We also call them endogenic or endogenetic forces. These result in the formation of features on the surface of the Earth called landforms. Once created, these features are acted upon by agents and forces that operate from the exterior of the Earth, the external landforming processes. These often reshape and remodel the landforms, sometimes resulting in the formation of new features. The forces that drive the external landforming processes are called exogenetic or exogenic forces or forces of denudation. Denudation is the destruction, wastage and removal of part of the Earth's surface. External landforming processes include weathering, mass wasting, erosion, transportation, and deposition. In this chapter, we shall study weathering and mass wasting. Weathering is the mechanical or chemical breakdown of rocks due to the exposure near the surface of the Earth. We say weathering occurs in situ, meaning the weathered materials do not move but remain in their original position. Rocks are broken down when exposed to agents of weathering, which include air, water, heat, and biological organisms. There are three main types of weathering: mechanical, chemical, and biological. Mechanical weathering is the physical breakdown of rocks without any alteration to their chemical composition. It involves progressive breakdown of large rocks into smaller and smaller pieces over time. Mechanical weathering is driven by forces such as temperature changes, frost action, pressure release, rainwater, and crystal growth. Temperature changes. Now, during a hot day, the rocks are heated by the sun, causing them to expand. When it rains, these rocks are cooled by the rainwater, resulting in rapid contraction. This heating and cooling cycles causes stress within the rock structures, resulting in breakage. Changes in atmospheric temperature results in three types of mechanical weathering: block disintegration, exfoliation, and granular disintegration. Block disintegration is also called block separation. Here, blocks of rocks break away from the original rock along the numerous joints and bedding planes, which are lines of weakness. The alternate heating and cooling over a long period of time cracks the rock along these lines of weakness, resulting in formation of blocks. Exfoliation is a process in which rocks peel, resulting in the formation of carved rock shells. This results from unequal expansion and contraction of layers of rocks. Since rocks are poor conductors of heat, the surface heats and cools faster than the inside, causing the outer layer to break off, leaving the rock mass beneath. The process is also called spalling or onion weathering. Granular disintegration is common in coarse-grained intrusive igneous rocks such as granite and coarse clastic sedimentary rocks such as sandstone. Here, the rock breaks up into small particles or grains caused by alternate heating and cooling of the rock. Next is frost action. Another important agent of mechanical weathering is the freeze and thaw cycle of water. First, rainwater collects in cracks in the rock. When this water freezes, it expands. This expansion exerts enough force to break the rock apart. The process is also called frost wedging. Through repeated cycles of freeze and thaw, frost wedging is capable of shattering the strongest of rocks. Crystal growth. Now, this process occurs commonly in dry climate and involves the growth of salt crystals within rocks. Rainwater containing some amount of dissolved minerals collects in cracks or on the surface of the rock. During the dry season, the water evaporates, leaving behind the salt. This cycle continues over a long period of time, and the salt crystals grow in size and slowly shatters the rock into small pieces. Rainwater. Rainwater causes mechanical weathering through a process called slaking. It is common in rocks with high amount of clay existing in wet and dry climates. During the wet season, the rock absorbs water, making them swell. During the dry season, they lose the water and shrink again. The process repeats over a long period of time, thereby weakening the attachment of individual particles, and the rock starts to break apart. And finally, pressure release. This process is also called unloading. Deeply seated rocks are believed to be under intense pressure from the overlying materials. When denudation removes this weight, the rocks become exposed at or near the surface of the earth and expand slightly, leading to large shells of rocks breaking away from the original rock mass. Next is chemical weathering. This is the breakdown of rocks by alteration of the chemical composition of the minerals that make up the rock structure. In the process, the original rock crumbles into softer mass and the rock is said to undergo decay or rotting. Chemical weathering is facilitated by the presence of moisture, gases, and high temperature. There are a number of processes involved in chemical weathering. Solution is the simplest form of chemical weathering, and it involves dissolving of some minerals within the rock in water. For example, rocks that have salt or halite in them. When water interacts with this rock, it will dissolve the rock, thus weathering the rock away. For instance, in this picture, when the salt interacted with water, all the halite dissolved in water and came out from the rock. So you can see all these crevices that were occupied by the halite. Carbonation involves the reaction of some minerals with weak carbonic acid. Rainwater dissolves some atmospheric carbon dioxide to form weak carbonic acid. When this acid falls on limestone rocks, that is rocks with calcium carbonate, it reacts to form soluble calcium hydrogen carbonate and the stone weathers away. This is evident by the features found in limestone areas that we shall see in later chapters. Hydration is the process in which certain minerals in the rock take up water, causing them to swell. This causes the rock mass to expand, creating internal stress within the rock, leading to disintegration. Oxidation is the process that occurs in rocks containing iron and in the presence of moisture. The process involves reaction of iron with oxygen in the presence of moisture, resulting in rusting away of the rock. And finally, biological weathering. This is the breakdown of rocks due to activities of living organisms, that is plants and animals. Action of plants. Now, sometimes plants' roots grow into the joints and cracks in rocks. As they grow, they expand, exerting pressure on the rocks and therefore widening the joints. Eventually, the rocks yield to this pressure and break away. Others like mosses and lichens grow on rock surfaces, releasing organic acids that break down the rocks. This is a combination of both chemical and biological weathering processes. Action of animals. Now, burrowing animals such as moles, insects and earthworms slowly breaks down small bits of rocks from the main rock beneath the soil and bring it to the surface. Large herds of animals such as elephants stumble on rocks as they move, breaking these rocks into smaller and smaller pieces due to their weight. Action of people. Of all processes, human activities is the fastest in weathering of rocks. Huge rocks are broken apart by blasting using explosives during quarrying as well as mining. The rocks are also dug from beneath the soil and are hence exposed to other agents of weathering. Although we have discussed each type of weathering in isolation, the truth is that all these processes occur simultaneously and none happens to the exclusion of the others. For instance, constant heating and cooling of rocks resulting in cracking of the rocks in mechanical weathering. Rainwater collects in these cracks and may freeze during the cold seasons, forming ice. The ice expands the crevices, causing the rocks to break into smaller pieces. At some point, plants may grow on these crevices, and as they grow, they require more space for themselves, resulting into further breakdown of the rock. The roots of some plants produce acids that further aggravate decaying of the rocks. Next, we look at the factors influencing weathering. Now, the type of weathering taking place in any region and the rate at which rocks are weathered are both influenced by several factors, which include climate, topography, chemical composition of the rocks, and biological organisms, amongst others. Climate has a significant influence on both the type and rate of weathering affecting a particular rock. The main elements of climate which are influential in weathering are temperature and precipitation. Since different regions of the world experience different climatic conditions, weathering processes vary from one region to another. The type of relief occurring in a region also influences the weathering process taking place in that region. In highland areas where the slope is steep, the weathering process is faster than in the lowland areas where the slope is usually gentle. On steep slopes, the weathered materials are washed away quickly, thereby exposing the rock surface to more agents of weathering. The variation in color and mineral composition of a rock also influence weathering. Rocks which are dark in color absorb more heat than shiny rocks which tend to reflect most of the sun's rays. Dark-colored rocks break up more easily than light-colored or shiny rocks. Finally, significance of weathering. Now, Weathering is the initial stage in the formation of soil. It breaks down the initial rock mass into smaller fragments, thereby preparing the rock materials for formation of soil. The depth of soil therefore depends on the extent in which rocks have been weathered. Weathering weakens rocks, making them easier for people to exploit, for example by quarrying or mining. Some weathered rocks like the granitic tors are fascinating and thereby act as tourist attractions. Next, we'll look at mass wasting. Now, mass wasting is the downslope movement of rock materials due to the influence of gravity. When such movement occurs after the materials have been lubricated by rainwater or water from melting snow, it is referred to as mass movement. The force involved in this movement is gravity, but it is only able to exert its influence when the materials overcome their initial resistance to movement. This initial resistance is caused by the friction between the materials and the underlying rock mass. Water plays an important role in helping the materials to overcome this resistance. Most movements of materials are slow, but sometimes they can be sudden and rapid. Slow mass wasting is the slow but steady movement of salt and loose rock debris down a slope. It may be so slow that it is not easily noticeable, as materials may be creeping. There are 4 processes by which materials may creep. These include soil creep, talus creep, rock creep, and solifluction. Soil creep is the steady movement of soil and other fine materials along a very gentle slope. It can push fence posts and telegraph poles from their original positions so that they appear inclined. Next is talus creep. Now, the mass of broken rock particles which accumulate at the base of cliffs and scarp slopes is called talus. This mass moves gently and slowly downhill in what is referred to as talus creep or scree creep. Now, rock creep occurs when individual rocks move down the slope at a very low speed. This usually happens if such rocks are lying on clay. In the presence of moisture, the rocks may slowly creep downhill. Solifluction is the movement of saturated soil, gravel and weathered rock materials down a moderate slope. Solifluction occurs on mountain slopes and in areas that experience cold climates. During winter, the water in the soil becomes frozen, thus freezing the soil as well. During spring, the weather is warmer and the topsoil begins to thaw. Over time, this soil becomes saturated with water while the subsoil remains frozen. The condition where the subsoil is permanently frozen is known as permafrost. The saturated mass of the topsoil begins to creep over the permafrost. Next is rapid mass wasting. Now, there are instances when the mass wasting process is sudden and fast. Rapid mass wasting is dangerous and destructive as far as property and life are concerned. It may occur in various forms such as flowage, sliding, or falling. Here are some common forms of rapid mass wasting. First, earth flows. Now, in humid regions, the materials on the surface get saturated with water, causing them to flow downhill under the influence of gravity. This type of movement is common on terraces and on the hillsides. When an earth flow occurs, it leaves behind a shallow scar, the original position of the material. At their destination, the materials form small bench-like terraces. Next, mud flows. This type of mass movement occurs on moderate to steep slopes, especially where the soil is bare or is covered by scanty vegetation. Heavy rainstorms produce more rainwater than the soil can absorb, and as the water flows downhill, it turns the soil into mud, which then flows in large quantities. With increased water, an earth flow can turn into a mud flow, which then flows in large quantities through specific channels. A landslide is also called a landslip. This is a rapid movement of a large mass of earth and rock down a hill or a mountainside. Little or no flowage of the materials occur in the early stages. Heavy rain and the resultant lubrication by the same rainwater facilitate the movement of the materials. The water content in the materials is, however, small. The common forms of landslides are slump, debris slide, rock slide, rockfall, and avalanche. A slump is a type of landslide which involves shearing or tearing away of the rock materials along a concave plane. It is common on very steep slopes like scarp slopes and steep hillsides. It involves large masses of rocks and loose materials as well as vegetation. A debris slide is also called an earth slide. Accumulated rock debris and other loose materials, which are products of weathering, may suddenly move downhill as a whole mass without breaking up. There is usually no back tilting of the mass, but the movement is horizontal. The materials accumulate at the base of the slope.
Oh my God.
A rock slide is a movement that involves a mass of rock which slides down a gentle slope. The surface over which the mass of rock is sliding may have been formed by a fault or a weakened bedding plane. A movement is facilitated by water, which lubricates the slip surface on which the materials are sliding. A rockfall is the most rapid form of mass wasting. It involves individual rocks or boulders that fall or roll freely from a steep slope or a vertical slope like a cliff. The falling materials can be as small as a sand grain or as large as huge blocks of rocks. This depends on the overall steepness of the cliff and the manner in which the rock breaks up. An avalanche is a sudden sliding and falling of a large mass of snow, ice or loose rock materials down a mountainside. Avalanches are common in temperate lands, especially during winter or spring. Accumulated quantities of snow usually break away and slide over the older, more hardened snow surfaces. And now let's look at rainwash. Now, rainwash is also referred to as downwash. It is the movement of loose surface materials down a slope, especially in dry areas which have a lot of loose materials and scanty vegetation on the surface. This type of mass wasting is usually caused by the heavy rainfall which falls in the tropical regions after a long dry season. The first raindrops scatter the soil particles, loosening them further. The running water from the increased downpour washes large quantities of the loosened soil downhill in two ways, These are sheet wash and gulling. Sheet wash is sometimes referred to as sheet flooding. In this form of rainwash, the solid is uniformly removed from a large surface on a slope by heavy rainfall. This form of rainwash is commonly on gentle sloping land where the slope is uniform and the land is relatively even over a large area. On steep slopes where the ground is irregular, running water flows downhill along specific channels. As it does so, it carries with it the loose soil materials. If the layer of soil is deep and loose, the water washes away large quantities of soil. This results in the widening and deepening of the channels where the water is flowing. The enlarged channels are called gullies. Now, mass wasting has a considerable effect on both the physical and human environment. When materials break away from a hillside, for example when a slump occurs, they leave behind scars on the land. That part of the hillside then becomes barren, leaving it exposed to agents of soil erosion. As materials of mass wasting move over the land, they physically remove other materials like soil and vegetation, thus increasing soil erosion. Mass wasting can also cause untold damage to property and loss of life. Some forms of mass wasting destroy telephone lines, roads, railway lines, fences, hedges, and stone walls.